Have you ever wondered how many intelligent civilizations might be out there in the vastness of space? The famous Drake equation gives us a theoretical estimate suggesting there could be millions of planets capable of supporting intelligent life. But here's the strange part, we haven't found a single one. Not even a whisper of communication, not a trace of civilization, not even a fossilized hint. It's like we're alone in a giant, echoing cosmos. Planets like Venus and Mercury sit far too close to the Sun to ever be good candidates for life. Their conditions are harsh, hostile, and practically impossible for any known life form to survive in. Then as we move outward, past Earth and Mars, we find ourselves facing the gas giants, Jupiter and Saturn. While impressive in size, these planets are made up of thick gas layers and don't even have a solid surface to stand on. Due to their extreme distances from the Sun, these gas giants also lie outside what scientists call the habitable zone, the area where temperatures are just right for liquid water to exist. So that's a big problem if we're looking for life like ours. These massive planets, while fascinating, aren't giving us the answers we're looking for. But that doesn't mean the search is over. Their moons, surprisingly, have become a new hope for astronomers. These smaller bodies orbiting the giants might just have some hidden potential. Some of them show qualities that hint at the possibility of supporting life. Maybe not now, but perhaps sometime in the distant past or future. And among all these mysterious moons, one stands out with fire, fury, and unmatched energy, Jupiter's moon Io. Let's take a closer look at Io, the fourth largest moon in our solar system and the most volcanically active world we've ever discovered. This tiny world might not look very welcoming, but it's full of fascinating surprises. It lies around 628 million kilometers away from Earth. That's a long way off. If we were to send a spacecraft there, it would take at least 4 years just to enter its orbit, and even longer to safely land on the surface. Io is one of the 4 Galilean moons of Jupiter, named after the legendary astronomer Galileo Galilei, who first spotted them back in the 17th century. And while Io ranks 4th in size among the moons, it holds the title for being the densest one of them all. Unfortunately, it also has the lowest water content of any known astronomical object in our solar system. That's already a major red flag when it comes to supporting life. Water is essential, not just for humans but for almost all known biological processes. But before we completely write Io off, let's dig a little deeper into the data. Maybe there's more to the story than we realize. What Io lacks in water, it more than makes up for in extreme activity. This moon is constantly erupting, with over 400 active volcanoes spread across its fiery surface. These volcanoes release massive amounts of sulfur dioxide that can shoot as high as 500 kilometers above the ground. That's taller than any volcano or mountain here on Earth. It's truly mind-blowing. Some of Io's volcanic eruptions are so powerful, they can actually be observed from Earth using large telescopes. The reason behind this intense geological activity is something extraordinary, a gravitational tug-of-war. Jupiter's immense gravity pulls on Io with great force, but that's not the only factor. Io's 2 neighboring moons, Europa and Ganymede, also play a key role. Their smaller but carefully timed gravitational pulls add to the tension, creating constant internal stress inside Io. It's like the moon is being kneaded and squeezed over and over again. That pressure builds heat, and that heat fuels the non-stop volcanic activity. Because of its orbit, which stays about 422,000 kilometers away from Jupiter, Io constantly cuts through Jupiter's strong magnetic field. This interaction turns the moon into a massive electric generator. It can build up a potential of about 400,000 volts across its surface. That's enough to create an electric current of roughly 3 million amperes. This electric current flows along magnetic field lines and causes spectacular lightning strikes in Jupiter's upper atmosphere. It's a wild and beautiful display of cosmic energy, one that's both terrifying and fascinating at the same time. Most moons in the solar system are icy, covered in frozen crusts made of water or methane. But not Io. Its crust is made of silicate rock, and beneath that is a molten core rich in iron and iron sulfide. This makes it a very different kind of moon. As the volcanoes constantly spew sulfur into the sky, the material settles back down, layering the surface with colorful patterns and vivid shades of yellow, red, black, and even green. It looks more like an abstract painting than a celestial body. Mountains rise dramatically across the landscape, some even taller than Mount Everest. But despite all this drama, Io is still small. Its radius is only 1,821 kilometers, and its total mass is just 1.5% of Earth's. It's also brutally cold. The average surface temperature reaches -143 degrees Celsius. Combine that with the toxic atmosphere, made up almost entirely of sulfur dioxide, and you get an environment that's incredibly harsh for any living thing. And if that wasn't enough, there's one more bizarre phenomenon that happens every single day on Io. As Jupiter moves between Io and the Sun, the Moon gets cut off from direct sunlight. It's plunged into total darkness and the temperature drops even further, down to a staggering -270°C. That's almost as cold as space itself. During this icy blackout, the sulfur dioxide in the atmosphere condenses and falls to the surface like snow. In simple terms, Io's atmosphere collapses every day. It vanishes for about 2 hours, only to return when sunlight reaches the surface again. As the temperature rises, the frozen sulfur dioxide begins to sublimate, changing directly from a solid back into gas, and the atmosphere is reborn. This daily cycle is one of the most extreme and strange things we've seen in our solar system. Imagine being on the surface during this collapse. One moment you're walking through toxic gas and volcanic heat, and the next moment everything freezes and the air literally disappears around you. So if we ever decide to visit Io, we'll need to be extremely careful. We would have to stay far away from hundreds of volcanoes, prepare for daily atmospheric collapse, and somehow survive in an environment with no water and barely any gravity. That's right, Io's gravity is just 1/5 of Earth's. That means moving around would be difficult. Think of it like walking on the Moon, but with an added danger of falling into hot lava or being suffocated by a collapsing sulfuric sky. It's as terrifying as it is fascinating. And here's the strangest part. Despite all of this, some scientists believe that Io might not be entirely lifeless. Astrobiologist Dirk Schulz-Makuch from Washington State University suggests that while the surface is absolutely hostile, the rocks below might offer something interesting. It's possible that beneath all the chaos, there could be hidden pockets where life, perhaps something completely alien to us, might survive. He argues that just because a place looks extreme doesn't mean we should label it as dead. Maybe Io was once a more hospitable place in the distant past. And maybe, just maybe, some form of life still exists there, clinging to survival deep underground. Since Io is, on average, 628 million kilometers away from Earth, getting into its orbit would take at least 4 years, plus additional time to land. It's one of the 4 Galilean moons of Jupiter, discovered by Galileo Galilei in the 17th century. Although it's the 4th largest moon in our solar system, Io has the highest density among all moons. In contrast, it holds the lowest amount of water of any astronomical object in the solar system. That's already bad news for potential life, but let's keep going before jumping to conclusions. If the lack of water wasn't already discouraging, brace yourself for the volcanoes. Io is the most geologically active body in the entire solar system, home to over 400 active volcanoes. These volcanoes eject sulfur dioxide that can shoot up to 500 kilometers into the atmosphere. Some eruptions are so massive that they're visible through telescopes from Earth. This extreme activity is caused by an intense gravitational tug-of-war, Jupiter's massive pull, combined with the precisely timed tugs from 2 neighboring moons, Europa and Ganymede, creates enormous tidal heating inside Io. Orbiting just 422,000 kilometers from Jupiter, Io cuts through the planet's powerful magnetic field, essentially turning the Moon into a giant electric generator. It can generate up to 400,000 volts across its surface and drive an electric current of 3 million amperes, which even causes lightning in Jupiter's upper atmosphere. Unlike most moons in the solar system that have icy exteriors, Io's crust is primarily silicate rock. Beneath that crust lies a molten core made of iron and iron sulfide. Continuous volcanic activity spreads sulfur across the surface, creating rivers of lava and painting the Moon with bizarre, vibrant patterns, yellow, red, black, and green. Enormous mountains dot its surface, some taller than Mount Everest. Despite its violent environment, Io is relatively small, with a radius of just 1,821 kilometers and a mass only 1.5% that of Earth. The surface temperature rarely rises above -143°C, and its atmosphere is composed mostly of sulfur dioxide, about 90%. If you thought that was extreme, here's another bizarre fact. Each day, Io's atmosphere literally collapses. When Jupiter passes between Io and the Sun, the Moon is cast into total darkness. Temperatures plummet to -270°C, causing the sulfur dioxide gas to freeze and fall onto the surface like snow. For about 2 hours every day, Io's atmosphere disappears entirely. When sunlight returns, the frozen gases warm up, sublimate, and recreate the atmosphere. It's one of the most unusual and dramatic daily transformations in the solar system. For any human mission, these conditions are a nightmare. Imagine landing on a surface riddled with volcanoes while preparing for the air around you to freeze and fall to the ground every day. No organic molecules have ever been detected there. Without any liquid water, survival would be nearly impossible for human life. Water scarcity would be a critical issue. And even basic movement would be a challenge due to Io's gravity being just 1/5 that of Earth. You'd experience something like walking on the moon, only with random lava flows and collapsing sulfuric weather systems. All signs point to a hostile environment where life as we know it cannot survive. Still, hope isn't entirely lost. Astrobiologist Dirk Schulz-Makuch from Washington State University believes life on Io's surface is impossible, but possibly not beneath it. He suggests that if you dig deeper into the rocks, things could get more interesting. Just because Io seems lifeless on the surface doesn't mean it's dead inside. In fact, in the distant past, Io may have had much friendlier conditions. There's evidence suggesting that Io formed in a region rich in water ice, especially when compared to its sibling moons, Europa and Ganymede. The intense heat generated by gravitational interactions could have once melted this ice, possibly creating temporary pockets of liquid water, a crucial ingredient for life. That early environment could have given rise to microbial life, and it's not impossible that some form of it could still survive beneath the surface even today. Io is a violent, alien world that offers a glimpse into the chaotic processes that shaped our solar system. It may be the most inhospitable moon for human life, but its wild nature tells us valuable stories about the formation of planets and moons. It's a world of fire and lava, of collapsing skies and flowing sulfur, a place that almost certainly can't support life as we know it, but perhaps, just perhaps, something unknown could be hiding below. So, how was your trip to Io with us? Let us know in the comments. If you'd like us to keep creating more fascinating content like this, please consider supporting us using the Super Thanks option below. Even the smallest contribution can make a big difference. It's awesome viewers like you that help us make science more exciting, more engaging, and easier to understand. Thank you so much for watching.